So what about a logarithm of 1 and a logarithm of base b with base b? On logarithm of 1, base, what is a base to an answer, to an exponent, equals an answer. So a base to what exponent equals 1? Well, when the exponent is 0, the answer is 1. So then that must be the logarithm is 0. The exponent is 0. That's how we got an answer of 1, no matter what the base is, which is what it's saying right here. Does that make sense why it's a 0? You're really telling me an exponent when you're telling me a logarithm. So over here, base b to the what stays b. B to the what stays b. Well, if I'm not changing anything, isn't it b to the first? And also, if I don't see an exponent, then it must be a 1 anyway. So that's a 1. When these are a match, this is a 1. When this is a 1, this is a 0. But if you just do the loop swoop, where you loop it, swoop it, it'll be really easy to tell. Speaking of loop swoop, let's get a little better. So 10 to the what gives me 10,000. 10 to the what gives me 10,000. So what's the answer? What does x equal? What is the logarithm? What is the exponent? The exponent is 4. Isn't 10 to the 4th 10,000? Same is true for right here. 2 to the what equals 16. 2 to the what equals 16. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. That makes 4 times total. So what's my x? My x is 4. The log base 2 of 16 is 4. That's how you say it. Log base 2 of 16 is 4, equals 4. So what about this guy? When you don't see a base, it's understood to be 10. It's called the common logarithm. It's like how we have, or customary. We got the metric system, we have the customary system, we've got 10 digits, 10 places, 10 digits to the next place. So the common log is base 10. It doesn't have to be seen. If you don't have a base there, like you didn't have a base 2 or a base, well, that was a 10 over there, so you didn't have base 2, if it's not saying it, it's a 10. So this is saying 10 to the what equals a quarter. 10 to the what equals a quarter. See this? I don't know. That means I'm going to have to use my calculator, especially because I don't see any way of connecting 10 to a fourth, to a quarter. So here we go. Control 10 to the x, which is how we get the log. Notice it's log base 10, and this is 10 to the x. They're connected for a reason. Now we're doing base 10 on this one, and we're going to do the answer of 0.25. So remember, log is a base of an answer, and then whenever you hit enter, it's going to equal the exponent, negative 0.602. So negative 0.602. 10 to the negative 0.602 is what gives you a quarter. It's going to take some getting used to. It's not difficult. As long as you understand what bia and bay mean, you're pretty solid. You're pretty good. And remember, this is exponential form. This is logarithmic form. If you want to convert from a logarithmic to exponent, you loop swoop. If you want to convert from exponential to logarithmic, you have to know that log is bay and exponential is bia. So we're going to bia bay. So we'll have to put the log of the base. So log base b of the answer equals, remember, a log is an exponent, equals an exponent. So this goes here. Okay, so now let's talk about Euler's number base e. Again, that thing is not going away. That's 2.71828, etc. We're still finding applications and uses for it. It's pretty amazing, actually. It has a lot to do that, obviously it's a little above our pay grade right now. But I want you to know it's very important base E, natural base. So here's what I need you to know. Natural log, right there, is the ln on your calculator. It is the logarithmic form of the exponential form when the base is e, when the base is 2.71828. So think this through. We're in exponential form. An exponential form is BIA, a base to an exponent equals an answer. So the base is e, the exponent is x, and the answer is y. When you convert to logarithmic form, log is bay. So the base, log of the base is e, 2.71828. So log base e of the answer is y. It's right there, pointed. And that equals the exponent. The exponent is x. That's this right here. That's how we got it. Now, people don't say log base e. They say instead ln. I need you to know this. If you put log base e instead of ln, the natural log, nothing is wrong with that. Nothing's going to happen to that. It's the same thing. But people don't use it. Mathematicians don't use it. They say ln. I don't know why they don't say nl for natural log. I don't know. I haven't a clue. But it's ln. That's understood. When you're looking at your calculator, you'll notice right here is the e to the x. But then if you do control e to the x, oh, look at that. It's ln. Ooh, fancy. I just made that really fancy. So something that, well, that'll be for later. But so I want you to know they're connected on the calculator, whether you have an 84 or an Inspire, for the same reason. They go together. They're complementary of each other. Okay, so more on that in a different lesson, but that's just going to get you introduced to it. Now, let's talk about properties. Okay, think this through. Logarithms are exponents. They're just a different way of writing them. That means our exponent songs, they also apply. They're the same. Check this out. When you multiply the variables, you add the exponents. Logs are exponents. That's what I'm doing. When you divide the variables, subtract the exponents. Logs are exponents. And then this guy, now remember, a log is an exponent. An exponent is also called a power. So this is a power raised to a power. A power to a power, you multiply the powers. The shortcut is I just drop it down in front and show that's implying multiplication. So these three properties are how we expand or reverse that and condense logarithms. It's actually really easy. It's really nice because it just follows our exponent songs. So you can use these to evaluate, sure. You're going to have a calculator anyway for most of this stuff. So you always have that to fall back on. However, there is always going to be a non-calc part to your test, and probably one or two or all three of the quizzes, I can't really remember, you'll not be able to use a calculator on them. So you have to know how to do this stuff. Now, let me give you this example. So let's practice using our log properties. I'm going to clear this out. Okay, so you're being told log base 3 of 12 is approximately 2.262. You're also being told log base 3 of 2 is 0.631. Evaluate the following. So how am I going to connect and evaluate for log base 3 of 6? Well, How do you connect 12 and 2? Can't you take log base 3 of 6 and instead write that as 12 divided by 2? Log base 3 of 12 divided by 2. Not multiplication, that's of. If I need to explain that a little bit better, maybe I need to make this a little smaller for you to make sure you see that it's like a subscript. It's a teeny tiny, there we go. Okay, so log base 3 of 12 divided by 2. Well, how can I use that? Well, when you divide those variables, you subtract their exponents, their logarithms. So what this really is log base 3, that's a teeny tiny little 3, of 12 minus log base 3 of 2. And since I have that written down right here and right here, what I'm really doing is 2.262 minus 0.631. So my answer, that's going to encroach on the space for the other one. That's going to bug me. So my answer, well, what is 2.262 minus 0.631? If you really have to, you can go right back to it. Let me take that away. 2.262 minus 0 point or point, it doesn't matter, 631, 1.631. Okay, so now what are we going to do to evaluate the one in the middle? Well, how are you going to connect log base 3 of 12 and log base 3 of 2 again, but this time produce 24? All right, I think you probably know where this is going. That's log base 3 of 12 times 2. And when you multiply the variables, you add the exponents, you add the logarithms. So that is really log base 3 of 12 plus log base 3 of 2. Based on the information you were given, that would be 2.262 plus 0.631. Remember, you can go up arrow and highlight. Apparently that's 2.893. Okay, last one on this row. So how am I going to figure out how to get to 32 when I have already divided, I've already multiplied, and I don't see any connection with division or multiplication anyway to produce 32. So let's think about something a different way. Now 12 and 32, I don't see it, but isn't 2 to the 5th equal to 32? Yeah, it totally is. That's a 32, by the way. It's getting late and I'm getting tired. So if this is the same thing as 2 to the 5th, so these are equivalent, these are equal to each other. I see a power to a power. What do? You drop the exponent, the little power, down in front, and you multiply. Boom, boom, just like that. So this becomes 5 times, which showing it right next to it is showing it's multiplying. If you want to do that, that's fine. With parentheses, if you want to do a little dot to show multiplication, it doesn't matter. It is understood universally that whenever it's next to it, straight next to it like that, it is being multiplied. So then what is this really? This is 5 times whatever log base 3 of 2 is, which is 0.631. So what is that? What did I just do? There we go. 3.155. Okay.